Okay, welcome everyone to the Cleveland R user group. We have two talks tonight. I'll be the second one. Our first one is by Alec Wong, who's a data analyst at Progressive Insurance, and he's going to tell us about integrating R and Python.
All right, thank you. I'm going to share my screen here. Okay. Great. All right, thank you everyone for coming. And I'm really happy to be here to talk about the reticulate package. And you'll notice that this says Saturday is Columbus. On the slide, I reused this talk from that event. And I am looking forward to more discussion from users here. All right, so Arthur C. Clarke writes, any sufficiently advanced technology is indistinguishable from magic. And so for the next 15 minutes here, the reticulate package will be, to us users, indistinguishable from magic.
So Alec, real quick, can you go back to the first slide?
First slide.
Yeah.
The title?
How do you get a lightning on the slide?
Oh, this is a GIF. Okay, so a little aside. Hopefully, this doesn't eat too much. This is just a GIF that I've set using CSS as the background, the page background. Yeah. So yeah. Anyway, I'm using the Saringan package to make an HTML presentation. So you can do neat stuff like have GIFs on the slide like that.
Interesting. Nice.
So yeah, why Harry Potter? The wife and I are reading through Harry Potter. We're up to The Prisoner of Azkaban. And I felt that the theme was appropriate, if a little unoriginal, but more so appropriate now that we're edging into Halloween. And this webcomic is pretty old, but if I might take some liberty here, if Harry's speaking Python here, I'm going to assume that Gryffindor speaks R by default. All right, so the package, what's cool about it? There's a lot of things to like about it. The first is Rstudio develops the package, and so we know that it will be well maintained for a long time. You can use the Python console directly from the Rstudio IDE, and we can convert Python objects into R objects and vice versa. And we can view all of our Python objects right from the environment's pane. And if you so choose, you can stick with R syntax and just take that all the way, getting your Python work and R work done together. And so for people who haven't used Python before, one of the things that this package does well is it lets you use what you know, what you already know, to get started. You can continue to use the Rstudio IDE that you're comfortable in, and you can continue to use R syntax. And we'll show you how that works. So the first thing I'm going to go through is how to get set up. And this is maybe a little detailed, but I think it's good practice to use what are called virtual environments. Now, virtual environments are just a way to minimize or mitigate package conflicts between your various projects, which might use the different versions between them of Python or Pandas. And so using this sort of workflow, I can start with a clean installation of Python and any packages that I might require. So first I load up the reticulate package. And then this is just for information, but I can query and see what environments do I already have on my system. And here I'm going to assume that I didn't actually create an environment. So I'm going to do that here with the reticulate conda_create command. And so I'm going to name the environment. And this is going to be called reticulate Saturday. And I'm going to tell it that I want Python version 3.9 and Pandas version 1.3.3. Now, I included the version numbers there to show you that you can request the specific version, but you don't have to include those version numbers there. You can just leave it off and it'll just install the latest version of whatever the package is that you're looking for. And finally, we activate this environment using the use underscore conda env function, again, exported by reticulate. And it's good practice to use required equals true. Otherwise, it might use the base environment. And you want to be sure that you're using the right one for the job.
Does this require you to have Python installed on your machine?
Yes, yeah, but reticulate does have a function, I think, install underscore miniconda or something like that, that will just get miniconda for you, and then you can use everything. It's very quick and really easy to use. This slide shows that we can use the Python console directly from Rstudio by calling a function repl underscore Python. Now this slide doesn't quite do it justice, so I'm going to open this in R and show you what this looks like. So if I call library reticulate and then I call repl underscore Python, I'm going to see something interesting come up here. It says Python 383 triple arrow, and this tells me that I am now in Python world. I'm going to do some things that I would in Python. I'm going to create an object, and I'm just going to list my directory. And now if you have the right version of Rstudio, I think 1.4 and up, you can see the objects that you've created in Python in your environment frame. So here I can swap between R and Python and see what's in both worlds. If I hit exit, I can leave that, go back to R. But the nice thing about this is that the Python session is persistent. So this directory object that I made is still there when I restart the REPL and come back later. So that is really cool. I can also use Python in R Markdown. Like I said, this slide deck was created in R Markdown, and all of this code was actually executed in code chunks. And so here, I'm just going to compare the Python to the R execution here. Very simply, on the left, this is Python code. And I'm importing a module called platform, and I'm calling a function also called platform that tells me what system I'm running on. Here, Windows 10. And then on the R side, I'm going to show how to do that with R syntax. So I'm using the Python functions, but I'm using R syntax. So reticulate has an import function that does the same thing as import over here, just makes this module available. And I'm just putting that in a platform object. And here I'm accessing the function platform from the platform module and running it. The only difference here being the $, being the accessor that I use to obtain the function, as opposed to the period in Python. And so I'm going to show you what this looks like in our Markdown, just to drive this point home. This is the Python code, and you can see that this is in a code chunk. And instead of the indicator here being R, it's just Python. And so now if I say Python here, our Markdown knows to execute this as Python code. You can see that it's started in Python here. This is not R, this is Python. Contrast that to the next code chunk, which is an ordinary R code chunk, but it's using reticulate to run the same code. I can run any arbitrary Python code using this pyrunstring command provided by reticulate. And just for the sake of example here, I'm going to import the numpy package, give it an alias np, and then I'm going to create a vector, which is going to be the sequence from 1 to 9 using numpy. Now, reticulate provides this object, py, that lets us access objects in the Python environment, pull it out, bring it into our R session. And so if I use py $vec, remind you that I created vec in Python over here, I get this sequence, this vector, 1 to 9. Now, how do I know that's an R object, not a Python like a native Python list, I'm going to compare it to the same thing generated in R. So I'm going to use seq to create a vector 1 to 9. And then all equal shows me that rvec and pi $vec, they're the same thing. I can go the other way. Now I can pull stuff from R into my Python session. So first, what I'm going to do is load up in R the CO2 data set using data, the data function. And then I'm going to go into Python. This block here is native Python code, but Reticulate has exposed this R module that lets me pull stuff from my R session into Python. So the CO2 data frame is in my R session. I'm going to make a copy of it in Python. I'm calling it df in Python. And I print the first few rows just so you can see what it looks like. 3 categorical columns, 2 numeric. And then what the heck, I'm going to go the other way again. I'm going to use the py object again to pull that copy that is a pandas data frame back into R and print it. And here we see the data is the same, but more than that, the data types are the same. So here, type and treatment are factors, and plant is an ordered factor. And through all of this conversion, those types have been maintained. Those are the same. If we take this a little further and use reticulate with dplyr, all of this conversion and stuff will make you sometimes not notice that you're using Python at all. And I have an example of this from my job. I had an ETL routine that I needed to write. And the problem was I needed to interface with some Microsoft OLAP cubes, some special proprietary database that I could not find an R package that would let me interface with that. But I did find a Python module that was pi80md. So essentially, I wrote a Python package that just wraps around pi80md to send the queries, receive the data, perform some transformations. But then I wanted to use R's DBI package to upload the data back to SQL Server because I feel like it has the most convenient API, especially for uploading data to SQL Server. So once again, I'm going to go through the process, but this time with the worked example here. So I'm using the Conda environment that I've created. And this is created beforehand, and it's just called Foresight ETL. That's the name of the environment. It has a bunch of packages in it. And so now, once I run that, I'm in that environment using that version of Python and all the packages in there. I'm going to import the Foresight module, which is something that I, again, wrote that just wraps around pi80omd. And from that module, I'm going to pull out a bunch of things. First is a class, which has some methods associated with it, and then 3 functions. And I just want to note that when I pull these functions out, they're not converted to R functions. They stay as Python functions. The data is converted between R and Python when you call it. So this is the workflow, a very stripped down version of the workflow. The first thing I do is perform the query. And so in the Foresight module, in the Foresight class, I have a method for performing the query. And what that gets me is a data frame. Okay, so I've run the query, I've got an R data frame, and I want to perform some transformations on it. And so this is where those Python functions come in. And you might not even notice it if you didn't already know that they were Python functions. I'm piping this data frame into this function, add year, month columns. And then I'm piping that into a mutate step with 2 other Python functions in here operating on R's data frame columns. So these reference the data frames in R, but they're Python functions. And this is, I don't know, when I first saw this, this was like kind of crazy. I expected it to error out. And I was surprised that it didn't, but maybe I shouldn't be. because the developers at Rstudio are nothing short of wizards. So what makes this function work exactly? So generally, we kind of want to just operate as R would. And here, like most tidy functions, we have data. The data frame is the first argument because we're going to be piping the data into that. And then we're going to take a deep copy of the data frame here, mostly because pandas, depending on what you do, might alter the data frame outside of the function scope. And we don't want that to happen. So I can take a deep copy of it here, perform some transformations, and then return the copy, the altered data frame as a result. And that's for use outside of a dplyr verb. For use inside of a dplyr verb like mutate, generally what we just want to do is we take a vector or a list in Python, and then we return a list. So this is nothing more than a lookup. It's nothing complicated, but it's just, it takes a list and it returns a vector. That's it. And reticulate handles all of the transformations for us. Oh, okay. Well, I guess this link is broken, but anyway, this was a joke here. I'm going to skip over this. So a couple caveats, considerations, things not to forget, which is funny if you've read the books or watched the movies. Gilderoy Lockhart proceeds to forget everything right here. Number one, make sure to use required equals true when calling use conda environment. Otherwise, you'll use some random environments, usually the base environment, and it's unexpected behavior especially if you're calling a specific environment. So do that. It's also good practice to export your environment to a text file. Reticulate doesn't have any functions to do that yet, but the code is available down here in case you want to know how to do that from the command line using the conda commands. And not all Python objects are transferable to R and vice versa, but there is a list on the package website that defines what is and is not available to be converted on the fly. And with that, I'm going to tell you, award yourself 500 points for listening to me for these 16 minutes. And thank you. These are some of the resources that I made use of here. And I'll take questions.
All right, thanks, Alec. And I think you're already on the hook for 2022 for a Shringen slide creation.
Okay.
Have that in the back of your mind. I've got a bunch of questions, but I don't want to. Well, I'll get started so people can think. So those special objects like the pi, the py, and then the r, I just feel like there could, like, what happens if someone overwrites that accidentally? There's no reason to know that that's going to be a reserved word or something. Like, do things get weird if people accidentally overwrite those?
That's a very good question. Let's see if I can actually do that. Let's see. So here, there is the R object there. And if I overwrite it, then, oh no, I cannot actually do anything with that anymore. So I guess that is something to pay attention to. In Python, don't use R, and then in R, don't use Python. Or in Python, in R, don't use the pi name. So let's see. Oh, okay. So R might be a little smarter on its end. Nope. Okay, I can still overwrite it. But I'm thinking that the pi object is in some other location on the search path. So if I make something here, go back to R. I'm guessing it's in the reticulate package. That's search. Let me see. Yeah, okay. So it's in the reticulate package's namespace. but you can overwrite it if you put something in the global environment, because that'll come before the you search for the reticulate namespace. So in both cases, yeah, it seems like you'll just have to keep that in mind when operating with the transformation objects.
Cool. Other questions?
I don't have a question. I have more of a comment. So you can imagine what's going to happen when Alec leaves his position and someone has to deal with this stuff. Because like, I'm one of the people in our group that's like good at R. This is like way above me, but yeah, that's why I think R is not usually received well at Progressive, where it's like no one understands it. So my stuff's not that complex. Imagine his stuff. So good luck to whoever ends up with his stuff after he leaves. So yeah.
He's raising the bar for everybody. I know R and Python.
Yeah. I usually tell people like, if you have an R question, come to me. If I can't handle it, I'll send you to Alec. Because yeah, if he'll be like, here, so you do this in like 2 seconds, and I'll be like, okay, never mind. So
You're the triage.
yeah.
So could you help me understand why required equals true would not to be the default? I'm trying to think why.
Yeah, I don't know. Maybe Jim can touch on that. I would have expected the behavior to be, if the environment's not there, then just fail. But it seems to, at least in my experience, just use the base environment if it can't find the requested environment, which would just lead to failures later on if the right packages aren't installed. And it does so silently. So yeah, I'm wondering, Jim, if you could touch on that.
Haven't the faintest.
Okay.
Don't know. Yeah, I haven't done any development at all with reticulate, either in the package or actually using it. So cannot provide you any insight into that. But it might just be that like the base case, right, of someone trying to reticulate, they just want to execute some Python code. If it doesn't happen to be the right environment, oh well, at least I can execute something. So I think maybe was the rationale, that just run this. You might not, if we can't find the right Python environment, the one you requested, at least we're giving you something.
Yeah.
What I was thinking.
In the Python errors, if you're totally just missing something, the Python error is not so bad, right? You'd have a problem though if it was like a pandas version, like you had some legacy thing that used a pre 1.0 pandas. You gave it to your colleague and they ran it, and just download the latest pandas. Like it'll run, but who knows? Once that error is not going to be as interpretable whenever it does something,
right,
changes an assumption or something. So interesting. Another question I have is, so do you notice it being slower than just using Python, having to make all the copies? I mean, typically Python doesn't do as many, all that copies, where that's sort of.
Yeah, I'm sure you would, if you were to make this workflow, you wouldn't want to copy like individual vector elements or something like that. I'd imagine it most of the time you'd want to stick with like copying a lot of data, do as much as you can in one side before copying on again, because yeah, it's inevitable you're gonna run into this to overhead and copying, unless if I remember correctly, I think maybe the arrow data structure doesn't need to be copied. I can't remember. I might have read that on the reticulate website, because it's represented the same in memory, if I'm not mistaken. But most everything else, yeah, you're going to incur that penalty.
I see Brian's on. I don't know if he's able to comment, but I feel like I remember Brian doing an earlier talk that referenced reticulate and talked about some of the performance implications, but maybe I'm remembering that wrong.
No, there's there can be a lot of overhead due to copies. It depends on, not everything needs to be copied, as Alex said, but I was confused. The thing, when I was talking about DuckDB, I know that Wes had put a lot of effort. Wes used to work in finance, and so he put a lot of effort into, you know, things like as of joins and important time series computations and pandas. And when I ran them through reticulate, I was surprised at how slowly they ran. And I didn't understand, at first I didn't realize it was reticulate, but then I ran it just straight in Python and it was a lot faster. So there can be overhead that sometimes surprises you. I think reticulate is really good if, I mean, to you know, that first comment that this is hard to understand for somebody, right? Like, I think, you know, oftentimes there might be things in R that just aren't available in Python, or vice versa. And that's when it's kind of like Alec's whole reason for this, you know, you didn't have access to this interface to some database. And so, you know, it's useful for simple things. But you definitely, I mean, I wouldn't want to have like a complicated workflow based around something like this, because I think it would be fragile and hard for people to understand. Just my opinion.
Yeah, I know. I don't know if it's been updated since, but for a long while, this was the path for machine learning if you wanted a GPU involved. So, you know, the Keras libraries and other things like that, because the infrastructure on the Python side to get CUDA running was just so much better. It was not worth recreating.
I've had the same issue, but the reverse situation, where actually it's Python that's running slow because it's trying to run R2Py. Like the exact opposite situation. And stuff. R is a lot better at time series analysis than Python, just hands down. Which makes loading in certain things very difficult and stuff. But to get to the point, one of the things that, to make a counter argument to your point about not integrating the two, have you considered model ops and developing system like integrated workflow or the integrated system test kind of on your platform through GitHub Actions in order to solve that problem? Because that's what we kind of had to start to do at my organization, is to actually use R to monitor the connections between Python and R and back and forth.
I don't know. My comment was more broad than that. It was just, you know, there aren't a lot of people who are super expert in both languages in my experience, and it's kind of better to stick to one or the other in general. That's just my feeling.
Fair point.